So the formulas from 11.1 that you need to memorize are the formulas for circumference, and there's two of them. You don't necessarily have to memorize them both. Just know how to turn a diameter into a radius or a radius into a diameter if you, for example, only memorize this one. So this is the first one. It's just pi times diameter, or you can also memorize 2 times pi times the radius. Remember, if they give you a diameter, you have to divide it by 2 to make it a radius. Now, then the other formulas that you needed to know were the formulas to find the measurement of the arc length. So for the arc length, what you're going to do is you're going to take the measure of the arc in degrees and divide it by 360, and then multiply it by some form of the circumference formula, whether they're giving you the circumference already calculated, or let's say they give you a diameter. So instead of a capital C there, it's going to be pi d if they give you a diameter. Or if they give you a radius, then it'll be 2 times pi times the radius that'll go there. It's all going to depend on what is given to you, and then you're going to use one of these three forms for the arc length. So these are all the same. The only thing that is changing is whatever they're giving you for the circumference. Now, for this example here, when I did the warm-up before, I did it both ways. I did it leaving it in terms of pi and using the pi button. But for tomorrow's quiz, you're going to leave it in terms of pi. So all I'm going to do here, 13 is my radius. So I'm going to plug it into the formula, 2 pi r. All I have to do is multiply 13 times 2 and leave the pi symbol. Don't forget the units. Circumference is whatever the units are as they are. No square on circumference. So that would be the answer to this question, left in terms of pi. We don't touch the pi button. Then if they ask you to find the radius, given the circumference already calculated, we can still leave it in terms of pi. We're still using this same exact formula, the 2 pi r, but this time I'm going to replace the capital C with what they gave me. And now I'm going to solve for the r. So I'm going to first divide everything by 2. If you want to divide by the 2 pi at the same time, you can. But this will give me 24 equals pi r. And now to solve for the radius, to isolate it, divide by pi. And then the final answer left in terms of pi is 24 over pi feet. If it asks for the decimal, you would actually have to divide by pi. But again, we're leaving it in terms of pi. It wants me to find the length of the arc. So what I'm going to do here, this was the formula that I showed you on the first slide. We're doing length of the arc is equal to measure of the arc divided by 360. And because they gave me a radius, I'm going to put the 2 pi r here. I'm going to fill in. I'm solving for the length. I'm going to put the measure of the arc, which is 55. And then I put in the radius. It's a 9. And now I can start simplifying things. If you want to go ahead and simplify the 55 over 360, you can divide them both by 5. 360 divided by 5 gives me 72, and 55 divided by 5 is 11. I can multiply the 2 and the 9. Now, if it helps you to see this simplification, you can add a 1 under that 18 pi. And then now I'm going to simplify the 18 and the 72. And this will simplify. 18 goes into 72 4 times. And now my final answer is just 11 over 4 pi. And this was an arc length, so it's centimeters. This is how I want you to leave your answers tomorrow when it says exact. I don't want you to divide and tell me that it's 2 point something, 2.75. I want you to leave it as a simplified fraction. Next one, yes. So for the next one, it wants us to find the circumference of the circles. We don't need to do anything with that rectangle. We just need to know that this 16 is the diameter of both circles. So what we can do is we know that both circles, we could use the formula pi times d. So this one's 16 pi. This circle is also 16 pi. So just add them up, and left in terms of pi, 32 pi centimeters. Last two examples are going to have decimals, so I'm not going to go ahead. I won't do these. I already did them before, but again, we're not rounding anything, so don't worry about questions where you'd have to round. Now we're at the point of the new warm-up that you just worked on. The formulas that you need to know from section 11.2 are the formula to calculate area of a circle, and that's going to be pi r squared. So area is equal to pi times radius squared. The way that I remember that this formula gets the r squared and not just the r is all the units on any area question are always squared. So that's my way of remembering this one. The other formula that you had to memorize from this lesson is for the area of the sector, which is like the piece of pizza, and that's going to be measure of the arc divided by 360 times the area formula. Now, just like before, we could also change this pi r squared to just a capital A. So if they already give you, say, the area calculated, and they want you to find maybe the measure of the arc or something, we can also, should be sector, we can also use just a capital A. So these are both the same formula. The only difference is the variation of the area. That's going to go right there. So for this one, since they gave me a radius, I'm going to use the bottom one that I wrote. So it wants me to find the area of the sector, and it wants both areas, both sectors. So I'm actually going to do this green one first. So the area of the sector is going to equal the measure of the arc, which is 150 over 360 times pi times the radius squared. Now, I want it as a simplified fraction. So what we're going to do here is I'm going to start simplifying. So I get 15 over 36. I can also multiply and get 81 pi. And if it helps you to put a 1 there so you can see how to simplify the fractions diagonally, you can. Now, if your calculator actually simplifies the fractions for you, you could just multiply straight across and then hit your button and your calculator will do it for you. But if not, you're going to have to break it down by hand. I can divide this diagonal both by 9, make this a 4, and make this a 9. Nothing else simplifies, so I'm just going to go ahead and multiply now. So area of the sector is going to be 135 over 4 pi, and these are inches squared. So now I'm going to do this side, and to find its measure of the arc, what I need to do is 360 minus the 150, and that's going to be 210 for this area, or this measure of that arc. So it's 210. So now what I'm going to do is area of the sector, this one's the blue one, equals 210 over 360 times pi r squared, so it's 81 pi again. And again, if you want to put a 1 under it. Now, I could chop off the zeros again. I can also simplify the 36 and the 81. And I can, again, make this a 9 and a 4. Nothing else simplifies here. So now I'm just going to multiply 21 times 9. and I get 189 over 4 pi, and again, inches squared. If you did it on your calculator, this one, the 135, would give you 106.03 inches squared, and then this one would give you 148.44 inches squared. But I don't want you using the pi button. You're just leaving it in terms of pi. Next one, they want us to use the area of the sector to find the area of the whole circle. So again, same formula, but instead of putting in pi r squared, I'm just going to put in capital A. So for this one, area of the sector equals measure of the arc over 360, and I'm going to put a capital A here because that's what they're asking me to solve for. Don't go through the process of solving for r and then have to plug it back in. So I'm going to fill in what I'm given. I'm given the area of only that sector, 64.5. Measure of the arc is 110. And I'm solving for capital A. Now, if I want to simplify this, I could make this 64.5 equals 11 over 36 times A. To solve for A, I'm dividing by that fraction, which is really multiplied by the reciprocal. So I'm going to multiply both sides by 36 over 11. So what I'm going to do here is this will cancel. And then I'm just left with A, and I'm going to just leave it as a simplified fraction. A is equal to 2,322 over 11. And these were, it was an area, so centimeters squared. If you happen to have divided it, it doesn't go in evenly. You'd have to round it. And again, I don't want it rounded. This answer right here. So when it says exact, if you try to divide 2,322 by 11, and if it doesn't go in evenly, leave it the fraction. Next one wants us to find the area of the shaded region. And again, we're leaving it in terms of pi. So watch how we're doing this one. So here, the shaded region is the gray. I need to find the area of the rectangle. And then I'm going to subtract the area of the three circles. Because if you think about it, this little half here with this half makes a full circle. So I actually have 3 circles in my rectangle here. So now, my diameter is right here. The diameter is 6. But remember, for the formula of a circle, the area, I need a radius. So I need to divide that by 2 and make the radius 3. Now, for the area of the rectangle, it's just length times width or base times height. So 18 times 6, and the area of the rectangle is 108. Now, for the area of one circle, it's going to be pi times radius squared. So it's 9 pi. That's one circle. Now when I times it by 3, I get 27 pi. So then I'm going to put here 9 pi times 3, 27 pi. And that is my final answer left in terms of pi. If you were using your calculator, then this would have actually turned into 23.18 feet squared. They should be squared. Okay, so for 11.3, the first question is find the measure of the central angle. Remember, all you have to do to find the measure of the central angle is take 360 and divide it by the number of sides. So this was a 24-sided polygon. So divide 24 into 360 and you get 15. So the measure of the central angle is 15 degrees. Now, make sure you know the names of the polygon in case you get a question like this, because instead of me telling you it's a 24-sided figure, I might tell you that it's a decagon. And if you don't know that a decagon has 10 sides, you're not going to know what to divide by. The next one. Now, here is advice for the polygon questions. Take the time to write down these three letters, A, N, S, because those are the variables in the formula to find area of the polygon. If the problem starts out by already giving you the value of these three variables, then don't waste your time finding central angles and making triangles. Just write them down. So the apothem here is 5.5. The number of sides, I can count it. Now, sometimes I might give you, instead of giving you a picture, I might say find the area of a regular pentagon instead of giving you the picture. So this is a pentagon. So my n value is 5 sides, and then my side length is 8. Notice I gave you all the information you need. We don't need to bother to do any triangles, any trig, nothing like that. On tomorrow's quiz, there will be no sine, cosine, or tangent questions. So for the polygon questions where they're asking you to find the area, it's either going to be an equilateral triangle, a hexagon, or a square, because you can use your special right triangles. Unless I give you a question like this, where I already give you everything you need. Everybody with me so far? So now I just plug it in. So A equals 1/2. You can either divide it by 2 or multiply it by the half like this. 5.5 times 5 times 8. Once you put all these numbers in your calculator, you should be getting 110 centimeters squared. So again, take the time. A, N, S. My apothem is 6 square root 3. This is a hexagon. I can count the sides. It's got 6 sides. What I don't have is the side length. Now, whenever, and this is only for hexagons, whenever I give you a radius length of a hexagon, it's going to be the same as the side length. So this will be a little trick to help you save time so you don't have to draw the triangle. But I'm going to do the triangle, but just remember, whenever you have a hexagon, this radius of 12 is also the length of the side. It's a little trick, only for hexagons. Okay, now, if you didn't remember that, then what you would have to do is draw in the other radii, find the measure of the central angle. You would do 360 divided by 6. Central angle is 60. Remember, when it gets split, turns into a 30, 60, 90. And then you can label everything you have. So the 6 root 3 was my apothem. It's this side right here. And then they also gave me the radius, which was 12. And you're going to memorize that in the 30, 60, 90, this is x, this is x square root 3, and this is 2 times x. All we needed to find was x. But if you think about it, look what's staring at you right here. This is your x value. You could go through the process of solving it, or even solve this one, 2x equals 12, and x equals 6. So if this side is 6, then this side is 6, and notice 6 plus 6 is 12. So you could go through the process if you forget that if you're given a radius, it's the same as the side. If you forget, draw the special right triangle. So I have the 3 variable values that I need. So area is equal to 1/2 ANS, 1/2, and we're leaving it in simplest radical form. So number of sides is 6, side length is 12. I'm just going to multiply 1/2 times 6 times 6 times 12 leave the radical 3 alone for right now, and I get 216 radical 3. And this was area again, so centimeters squared. And that's how you're going to leave your answer. If you were asked to round to the hundreds place, then you'd have to figure out the square root of 3. And that would have been 374.12 centimeters squared. But I want it left exact, so you're going to leave it in radical form. Now I'm going to skip over example 4. 3 minutes. You already did it. The perimeter here is 99.41 inches, and the area is 745.58 inches, and that'll be squared. I will not give you anything where you have to use sine, cosine, or tangent tomorrow. I will go back and rework this one when we start to get ready for the test. This will not be on the quiz tomorrow. You will not need to use sine, cosine, or tangent tomorrow. Okay, so for the square question, this is not the apothem. It goes all the way to the side of the circle. This is a radius. And if I draw in another radii, now I've got a little right triangle here that I can work with. And I can do the 45, 45. So if I pull this out, and if I maybe put it in the same orientation, the right angle is here. This is 4. And this is equal to x square root 2. These two sides are x because the central angle in a square is 90. And when it's bisected, it becomes 45. So if I solve x root 2 equals 4, divide root 2, x is equal to 4 over square root 2. I got to rationalize, and this gives me 4 root 2 over 2. Simplify 2 root 2. Okay, so now this is x, so this is 2 root 2. This is 2 root 2. So this right here, 2 root 2. This is 2 root 2. Add them, and the side length is 4 root 2. Remember, back in your elementary school days, you can find the area of a square by just doing side to the second power. So I'm just going to do 4 square root 2 squared, and my area ends up being 32 meters squared. Now, if you didn't want to use the area equals side squared, you can also do area equals 1/2 ANS, because again, we already have everything we need. The apothem is the 2 root 2. The number of sides is a square is 4. The side length is 4 root 2. And then you can plug it in to the formula and get the exact same answer. Okay, and then we have section 11.4 here, and we have to determine if this is a polyhedron. This is not a polyhedron. It's a sphere, and because it's got a curved side. So not a polyhedron here. This one, yes, it is. And the shape on the bottom, since there's no congruency marks, I'm just going to name this as a rectangular pyramid. So when you're doing this on the quiz tomorrow, you're going to tell me the shape of the base, and then this word here is either going to be pyramid or prism, depending on the polyhedron. Then you're also going to have to identify the number of faces. This pyramid has 5 faces. It also has 5 vertices, and it also has 8 edges. Now, if you want to use Euler's theorem, it is optional. Remember, faces plus vertices should equal edges plus 2. So 5 plus 5 equals 8 plus 2. 10 equals 10. I did count everything correctly. And then the very last example. This is a polyhedron, so yes, it is. And the shape here, 1, 2, 3, 4, 5. This is a pentagonal prism. And then we're going to count the number of faces. There are 2 pentagon faces and 5 parallelogram or 5 rectangle faces, so 7 faces, 10 vertices, and 15 edges. And again, if you want to use Euler's to check it, faces plus vertices, 7 plus 10, should equal edges plus 2. 15 plus 2, 17 equals 17. I did everything correctly. So that is the warm-ups, which is a good way to review for the quiz for tomorrow.